Hello, this is Todd Lewis here from Mainline Dyno. This is going to be the first in a series of videos showing users how to use the CCS software and system. So this first video will just be mainly showing you the main screen when you come into the program, and I may show you some of the other screens that are in the program, but they'll be dealt with in depth in future videos. So righto. So this screen, upon opening the program, is the default. Essentially could be used for a steady state amongst other testing screens. It sort of takes the place of the dial screen on the Dyno system, but this screen is made up predominantly of three charts which are completely definable by the user. You can change the number of plot counts from just one large one to up to 4 if you wanted to. The default config when we ship a dyno is on 3, and these are all, you can change the sizes on here. So what these chart recorders do are essentially just scrolling live data from any particular channel you put in there. So in this mode, default config, we generally have the weather station channels up here on the top right hand side. There'll be a AFIR ratio 1 reading there and a lambda heater status. You can see here at the very top right that there's a little green thermometer indicating that there's valid weather station data coming in, and it's within the boundaries we've set to be classed as valid data. The green icon up here also means that the dyno main controller is connecting to the software. Down the bottom right hand side you'll see this mode off. So this is how you change from the different modes on this new CCS system. So off just means the dyno will do nothing as far as any loading whatsoever. So you can just drive on this screen here and it'll never feel any load. If you happen to go to the ramp screen, nothing would happen until you actually define the mode you want to use the dyno in. So if I just click it onto fixed speed, this would be the direct equivalent of using the dial screen in a Dyno system. So you can see here now, the top left there's a default of engine speed target of 2000. This is engine RPM, so that's the one main difference with the new CCS system. The entire program only shows you from a control perspective and display perspective an engine speed value, which is basically derived engine speed. It's a calculated value based off the gearing you enter into for the vehicle. So on this screen, basically if you wanted to move that, it's a function of page up and down like the Dyno system was. There are some keyboard shortcuts where you can move that in larger chunks as well. Alternatively, you can just click in the box and just type in the value and go to 4000. You'll see at the same time there is a road speed target which is actually changing based off that value, and you'll also see what's called a rotational speed target, which would be representative of axle speed. So that's so when I change this top box, you'll notice the other two boxes will change when I press enter. So that's now becomes the rotational speed target of the axle. You'll see down the bottom to left there's basically a torque balance boxes, which will be there, one for like across the back axle, and if it's a four-wheel drive one, it'd be across the front axles. There is it's turned on by default under here. There's a torque balancer function where I've just got rear enabled, so the program is constantly basically balancing the torque 50-50 side to side. So basically you would just drive on this screen from a loading perspective. You just drive and you would start to see power coming up, whatever you'd see live lambda values. The system was done. It has a 2-channel CAN base AFR meter, so the moment you turn the axle, you would see the actual lambda stator heatus would change, because it's actually the AFR meter has power continuously, but the system will only turn on power to the sensor heater once it detects axle speed. So the sensor heater is not on all the time, it's only when the dyno is being used. You can manually override it by clicking lambda heat. So you see here manual on, and it's got a 500-second timeout function, so it'll just have power going to the sensor now for 500 seconds, or you can turn it off via that function here. So now at the moment I don't have the control head unit actually connected to an actual dyno. I have the head unit connected to two what's called pod controllers, which would normally live down in each dyno pod. So we can see that by, if I just go to all channels, basically these two right columns here are showing you the channels that are coming back from each pod unit. So basically you can see here things like excitation voltages for speed sensors and load cells, temperature retarder sensors. There are some 4 analog voltage channels that are used in the pod controllers, for example, for the temperature of the retarder, and also like a feedback voltage of some components that are used in each dyno unit. So the fact that these we're getting data here proves that we're getting data back, and then, well, you can't see it in this video, the head unit would be indicating 2 green lights, meaning it's talking to the pod controllers. So if I just go back to the main screen, so because we're not connected to an actual dyno, that's why you're seeing this massive torque value of 91,000. So basically the load cell circuits are open circuit because I don't have it plugged into an actual dyno. I do have a valid weather station plugged in, that's why we've got valid weather station data. I don't have an actual lambda meter plugged into this system, so I'm not going to get actual valid lambda readings. So on this screen, if we were to use this screen, steady state, the whole time there is an actual 600-second continual logging loop happening. So if I click on the word data logging, you can see here there are user definable data logging pages. Once again, we've got some defaults that are in the system. Users can completely overwrite these. So if I was just to drive the vehicle on the front screen at any point in time, I can just click pause logger and I can go back to data logging, and I can basically then click on the screen and I can scroll back through. You can see here there's going to be 600 seconds of data, so I can move through that data and view any particular anything that happened on any channel in the last 600 seconds. So then I can click resume logger and it'll just keep logging. So that logger works continuous whether you're using this screen, the ramp screen, or any other function in the dyno here. So on this screen here, it's not only used for steady state speed, we could also change it over to what's called a fixed torque option, where then you can actually dial up a fixed torque target. So if I was just to press page up a little bit, now these numbers are round numbers based off Newton meters, but I could clicking here and just command 200 foot-pounds. So now if we were just driving the vehicle, the dyno would be basically applying 200 foot-pounds of load to the car. This is axle torque. If I went to say 1,000, it'd now be doing 1,000 foot-pounds of torque to the axles of the vehicle. So you can drive along with various load. You could go through the gears, you could run an engine in if you wanted to do this particular function. So it's one major big change on the CCS system compared to the Dyno system, is having this like a torque value target you can actually control. So, but just be careful using this function here. If you're pushing page up and just putting more and more and more load on, if the vehicle can't sustain it, it'll basically just stop the vehicle. So you have to be aware that you're going to have to press page down back to 0 pretty quick smart if you want to drop the load off when you're doing that particular test. So that's a quick overview of this actual front screen. Any of these digital boxes you see here, you can change. So if you want to see something different, for example, you can see if you hover your mouse over any box, you'll see the little spanner icon. So if I click on that, then there's a full drop down. If I want to just type in air, we've got airflow ratio 2, for example. So now it'll have the second airflow ratio channel that would be coming from the AFR meter. So that function is applicable right throughout the entire program, or wherever you see like a little spanner icon, you can actually go and change the channel. So, but bear in mind, continuously all channels are logged in the background continuously. So just because you don't have a channel displayed in a particular box, it does not mean you're not going to miss any data from them two particular channels. So to just be aware of that. Now, while I'm here, there's a function called drive test. Just drive, I should say. So you can see drive test and drive. So drive is effectively like road load mode, but it will only, so whenever the vehicle is accelerating, it will be putting effective load on the vehicle equating to if the car was accelerating. So you can just put the car in gear and just drive in this particular screen, and it'll just basically plot power, torque, whatever you want it to do. But if you then hold the vehicle steady state, the load will drop to zero because the vehicle is no longer accelerating. But so the point of the test would be, so if you can actually just take off from the dead stop, go through the gears, or you could just be rolling along at 60 kilometers per hour and just put your foot down and just let the car wind out, and it effectively give you the same power you get in a ramp test on this particular front screen. And likewise, because you've always got a data logger logging, you can always pause and go back and see what actually happened during the drive function on this particular screen. So I'll just go back off now, put it back to default, and here, so just to quickly go over what you see on the screen here, you'll notice there's a fan button up the top here. So just like a Dyno system, we can actually turn the fan on off, and it has a shortcut key for V. So on 99% of Pro hubs, for example, there's only really one relay being used, and that's to turn the vehicle fan on and off. There is the provision in the hardware of this system to switch 4 outputs, which are all totally configurable by the user, and you'll see the lambda heater button up here. So the only difference you may see across the top here is when a customer purchases what's called a VSD or VFD fan control, we can set up some things what's called like VSD fan control. So if I just click on show buttons in toolbar and it defaults to vehicle fan, you'll see there's some additional buttons up the top here now. So you'll see there's some things where you can configure some various profiles of variable speeds you can set up in this particular screen. So that's the only time you'll see extra buttons turn up at the top of the screen here. So what that means there, so as far as this VFD control is, or VSD control is, so for fan 1 it's called vehicle speed, input channels controlled by rotational speed. So when it's in a low profile, there's some settings here that, so between 0 axle RPM and 400 axle RPM, it's going to transition from 0 to 50 Hertz, so 0 to 100% output drive, and there's an override of 30 Hertz, and that's what the override button was on that particular screen. So if we're in the medium profile, things are a bit different, where it'll start from 0 to 400 axle RPM. So from the word go, the drive will immediately go to 25 Hertz or 50% if it's in countries with 50 Hertz control, and by the time you get to 400 axle RPM, it'll be doing 50 Hertz, it'll be full bore. And then once again, there's a different profile for high. These are all changeable by the user, so that's just an example there. Now if I went to fan 2, it would predominantly be like for cell fan control. So once again, same sort of deal, you can change all the parameters you want for your cell fan. Now the VSDs on the CCS system are controlled by what's called CAN open, not Modbus control like on a Dyno system. So this is basically done through a CAN open profile. So because all of the CAN based information is all hardwired into the main controller on this system. It doesn't go through USB ports and use USB to 485 adapters or USB to CAN adapters. It's all hardwired. So we can see some of that data if I were to go to setup and communications. Now this is in a user mode where the user can see what's called accessory CAN 0 and accessory CAN 1. But if I just click on the diagnostics tab, it'll show any live CAN data that the system's actually seeing at the moment. Now all that's showing at the moment is the data on CAN 0, which is basically the CAN bus which is controlling the pod controllers in there. So as I plugged in other data acquisition devices, maybe like an air ratio meter, or if you had like an ECU plugged in, you can actually see live CAN data here. So this is how you can actually use it to reverse engineer and confirm any data devices you're setting up actually work. So CAN 01, would be generally where this is where a mainline lambda meter is actually connected by default. But you would add a secondary thing. If you wanted to add another device, you could actually import some default like CAN files if you had them loaded on the machine anywhere. We've got some default ones that are loaded on Dynos by default. Accessory CAN 1, we have a default structure in here for GM broadcast data, where it's actually just getting a handful of the broadcast GM CAN data that's transmitted on GM cars, and we've got a default one there where it's actually just requesting OBD2 ignition timing. So that's some channels we're getting there as well. There is a transmit function to actually request the OBD2, which the users can actually set up. So all of this CAN information here is totally user definable. So people who are fluent in defining CAN communications, this is how they all do it here. So if a user wanted to set up to transmit anything like the dyno power and torque or anything out on a CAN bus, it's simple. The user just turns and makes a new basically data set, sets it up, and it's all done. And it is shareable and with any other user as well. So that's a quick overview of the CAN tab. But likewise on here, some of the other tabs, there's a ramp test tab, which is similar in operation compared to a dialing system. There's basically, now I'm just using one screen to show this function, but by default there's two screens on a CCS system, and users can opt for 3 or 4. So you'll notice there's a ramp test 2 is basically a duplication. So if you had two monitors, you would have ramp test 1 on your left screen and ramp test 2 on your right screen, and you can choose how many plot counts you want again on here once again, and all of these graphs that are in here. So by default I've got them set up for power and torque, airflow ratio down the bottom. You can grab hold of these and resize them. And these graphs, all of these windows in the graphing area are definable up to 8 channels in there at any particular time. So if you had 8 EGTs, for example, you could plot them live in a window and have it set up to show there. Ramp test 2, likewise, you can it's up to you what you want to display in the graphs. The drive test, it looks a similar function, but the drive test is it's a ramp test done using the road load force. So it's effectively, it does basically, the car ends up showing the same amount of power, but it goes from using it like a linear test function in this screen to using a road load force. So you'll notice it'll be completely non-linear based off the torque characteristics of the vehicle. So that's what the drive test is. And once again, there's drive test 2, which is just a secondary screen again, so you can choose to display what you want to display there. Once again, there's a drag test screen, where this screen here, it's basically over a test distance of 410 meters. The bottom of the screen here, it's not over engine RPM, so this is a time-based test in here. There is a little, if you were doing a legitimate test, it would have something like this particular drag tree on it. So basically you just roll your stage and then you go stage the second time and triggers the test automatically for you. So that's what the drag test is. Now the drag test is just a secondary screen for viewing data. So once again, it depends on what you want to display on the drag test. You don't have to display power. You could just simply plot engine RPM on the screen and show what's happening as you go through the gears, for example. So it's totally user definable. There is an analog function, to some degree similar to Dynalog, but the main difference here is users can change the x-axis to be whatever they want. The system is defaulted to derived RPM everywhere else where you're doing testing, but in the analyze screen, this x-axis here, for example, could be engine RPM, ECU RPM, for example. So if you had an automatic vehicle, you're going to see the way the data looks differently when plotted over actual engine RPM. So you can load in runs in there. And data grid, it's a function where basically what takes the place of the right screen on a Dynalog system. You can have these templates. Once again, you can you can make up to, click over here, view count, you can actually have 10 different preset tabs, and the users can do what they want with them here. So you can notice here I've just got an Atmos one, I've got one called tune data, just one showing retarder temps, for example. ECU channels you can put in here, some pressure channels. But if I wanted to add more here, I simply just go row count 3, I can go column count 5, for example. So you can just keep on adding boxes in here that you wanted to add. So if I just go back here to 4, so I know, for example, one of my channels I technically could get is just the ECU baro, so I'll just see what baro channels are available to me. So I can see baro pressure ECU, so that would now be showing the baro pressure from an ECU if that was coming across on the CAN data. So that's the data grid, and I quickly showed you the all channels tab before. So that's a quick run through the program, mainly designed to show you the front screen. On some next videos I'll show a bit about how to set up a ramp test, and then some data logging ones showing you how examples of data logging. So we'll call it quits on this video, and we'll see you on the next video. Thanks.